Hello. Today we're going to talk about 7.4 properties of logarithms. So the first two properties are very similar to your exponent properties. They're just kind of in reverse. So like when you add logs, you're going to multiply the arguments. When you subtract logs, you divide the arguments. Now notice you go in the order of how you read it. It's m minus n, so it's m over n. It goes in that same order. The power rule is just stating where the exponent can go. So if you have an exponent in the argument, you can also put it out front. So you can put it either way. All right? So it's whatever the argument is being raised to, the entire argument, you can just throw it out front. Okay? You also have the change of base formula. This is how you can insert a log into your calculator. I'll get to that in a moment. All right, first let's just deal with our properties. So how to smash all of these logs into one single logarithm. So log base 2 of something. Well, since it's all addition, we're just going to multiply. So log base 2, you do not do anything with the bases, but the arguments, you just multiply. So m times n times n. So this answer simply simplifies to log base 2 of m n squared. Okay? So this is your final answer. All right, for number 3. Well, I don't, let's see. We can either deal with the parentheses or leave that out front. A lot of different ways of approaching this. Let's see. Since we already have addition in here, I'm going to go ahead and combine those. So we know that's log base 6 of nm. Okay? Because it's addition, so we multiply. Well, then I know because that is out front, I can use my power rule and rewrite that as nm to the 7th. Right? I don't want anything out front. A single logarithm means nothing in front of it or outside of it. So everything's in either the base or the argument. All right. So now, since I'm raising both n and m to the 7th, we can write it this way. But usually we simplify it in the math world as n to the 7th, m to the 7th. Technically, both of those answers are correct, but I'm just letting you know how you typically see the answer. All right, number 4. All right, well here I can't combine those yet. I can't subtract that because I have a number out front. So let's move that as an exponent, and then we're able to subtract it. So then we do division. M to the 5th divided by n. Okay, so you can't add or subtract logs until you move the argument, not the argument, the base, the power rule. Okay. All right, so now we're going to go the opposite direction. So instead of squishing it, we're going to make the log much larger. So only one thing in the argument. So right now I've got way too many things. So I can separate this because it's multiplication. We can write that as addition. And then I don't like the power there, so I'm going to use my power rule and put it in front. And that's how I expanded. Now notice there's only one thing in my argument. That was my goal. Number 7, we have division. So rewrite that as something subtracting the denominator. Notice my base is still the same for both of them. I don't like that power, so I'm going to move it. So log base 2 of m minus 5 log base 2 of n. Okay. All right, if this gets confusing, I know it is. It's super weird. Okay, logs are super weird. This is where I lose a lot of kids. Okay, if I haven't lost you yet in Algebra 2, this is where I typically lose them. Okay, so if this gets confusing, just ask me. I'd be happy to keep going over it. Okay, or try a different direction. So let's see, number 8. This is division as well. So we're going to do log base 2 of 1 minus log base 2 of n. And you're probably thinking, well, that's way too easy. Well, yeah, it is, all right, because we can actually simplify this. Log base 2 of 1, remember your properties. Oh, it was on, dang it. It was on my other slide. So in 7.3, anything with a argument of 1 is just 0. So this is really 0 minus log base 2 of n. So we don't need to write that 0. It's just negative log base 2 of n. Okay. Always look to simplify your answers. Always look to simplify your numbers. Okay. So that's a key one I wanted you to pay attention with, number 8. Okay, so now we're going to evaluate. So this is all about plugging it into your calculator. So let me get my calculator out. So let's see. We want a log base 5 of 55. If we press this log, it does log base 10. It's a common log. Okay, so what we can do is we can rewrite this as a common log. Okay, and that would be log of 55 over log 5. The base goes on the bottom. It's always like this. Okay, the argument's on top. I get kids that mess that up all the time. So log 55 divided by log 5. Okay, so then I said, what, round to the hundredths? So the tenths hundredths would be that 8. The 9 is 5 or higher, so I round up. So it's going to be 2.49. Okay, again, let me show you again. Number 5, we do log of 5 over log of 4. The base goes on the bottom. So log 5 divided by log 4. 1.16. Okay, now that's how you do the change of base formula. You can also try, let's see, I believe it's in math. Yeah, you go all the way to the bottom, log base. And here you can actually change the base. So base of 1 of 100. Okay, uh-oh. It says there's an error. Why is there an error? Well, let's look at it algebraically. 1 to what power is going to be 100? That's never going to happen. Okay, never going to happen. Okay, all right, 1 to any power is always going to be 1. All right, so this one isn't real. It doesn't exist. It's you'd call it undefined. Okay, so this one is undefined when it doesn't make sense. It's not imaginary, all right, but it just doesn't make sense. Okay. All right, the last one. All right, we have log base 2 of 64. So here we go to this, and I'm going to change that now. So let's do base 2 of 64, and we get 6. Okay, you're probably like, well, that's really simple. All right, well, think about it. 2 to what power is 64? So that's how we got 6. So you can do it by your hand, all right, by logic, or you can do it with your calculator. Okay, so sometimes you'll get a decimal, sometimes you'll get something nice. Okay, so let's, using our properties, let's evaluate some logs. So first I would combine these. So here you get log base 3 of 9 over 27. Okay, well, log base 3, 9 over 27 simplifies to 1/3. We don't know what that equals, so 3 to what power is 1/3? X is -1. Okay, when we're evaluating logs, remember you get a log equals x. You can convert it to exponential form and then solve. All right, again, we can combine these by dividing them. So log base 3, 405 over 5. That's log base 3 of 81. We don't know what it equals. So 3 to what power is 81? Well, you know that is 4, right? 3 to the 4th power is 81. Okay, let's do another one. So here, I can't combine them yet because I have a number out front. So this is going to be log base 2 of 7 plus log base 2 of 16 to the 1/2. Well, 16 to the 1/2, that's just the square root of 16. So now we have log base 2 of 7 plus log base 2 of 4. We add those logs together, and we get log base 2 of 28. Okay, this one's not going to be nice. All right, if you plug that into your calculator, you should see 2 to what power is 28, something gross. Okay, so that's why I stopped there, because I knew it was going to be something gross. If you don't know, plug it in your calculator and just see. Okay. All right, let's do some more. So practice these, see what you get. Okay, so let's see. You add these, we get log base 3 of 7 times 6 is 42. 3 to some power being 42 would be really gross, so let's leave it like that. See, this one's gross. So this one over here, we get log base 2 of 5 squared minus log base 2 of 25. Log base 2 of, well, 5 squared is just 25 over 25. Log base 2 of 1, well, that's just 0. Anything to the 0, any log base of anything to 1 is always 0. All right, next one, we get log base 4 of 3 plus log base 4 of 2 cubed. So what's log base 4 of 3 times 8? So we get log base 4 of 24. Ooh. And that's not a nice number, so I'm going to leave it as a log, unless it tells me to round. Okay, so that's it for your basic properties of logs. But it's important to know some crazy weird problems. Okay, I like to throw these in there because it's more of a puzzle. Gets you kind of thinking about your properties. Gets you a stronger knowledge of logs. So let me show you what that means. So we want log base 10 of 18. Well, all we know is log 2 and log 3. But I want log of 18. Well, I can get 18 by doing 2 times 3 times 3. Well, if I can do that, well, then I can write it as log 2 plus log 3 plus log 3. Okay? All right, so then here we get 0.3 plus 0.48 plus 0.48. So what is that? 80, 96, 26, 1.26. Okay. All right, the next one, we want 20 over 3. Well, think about how you'd make that 20. We can make 20, let's see, all I can really think is 2 times 10 over 3. I'll show you why that 10, I'm not going to split that up. I'm going to leave it like that because I can write that as log 2 plus log 10 minus log 3. All right, because I'm multiplying the 2 and the 10 and I'm dividing by 3. So I'm subtracting the 3. Log 2 is 0.3. Log 10, that's 10. That's base 10. Log base 10 of 10, when these are the same, answer's 1, always. So minus log 3, 0.5. 0.48, we get our answer is, let's see, 0.82. There you go. I know, they're a little weird. Let's try another one. Okay, so we want 5. How can you get 5 with 2, 3, or 10? Okay, we can do log base 10. So this is log 10 divided by 2. So log 10 minus log 2. And we get 1 minus 0.3, which is 0.7. I know, we'll keep doing them. All right, let's try 13. Okay, so we've got, let's see, we've got division, so let's go ahead and subtract that. We get log 1 minus log cube root of 2. Well, that's the same thing as saying 2 to the 1/3. So this is log 1 minus 1/3 log 2, because when you have a exponent you can put it out front. It's the power rule. So now I have log 1, which is just 1, minus 1/3. Ooh, I'm sorry. Log 1 is not 1. Log 1 is 0. Log 10 is 1. Log of 1 is 0. And log 2 is 0.3. So your answer ends up being negative 0.1. Okay, and I know that these are tricky, so these are more like your bonus problems, but I think it really helps strengthen that knowledge of how logs work. Okay? Okay, so here's some more practice. Here you have log 4 and log 3. They still have base 10, so you can still use 10s to also make these numbers. So why don't you guys pause this and try it. Okay, so I want to make 12 work, so I'm going to do log 3 times 4. So that's log 3 plus log 4. So we get 0.48 plus 0.60, so we get 1.08. The square root of 3 is the same thing as saying 1/2. So we take the exponent, put it out front. Okay? So we get 1/2 of 0.48. So we get 0.24. All right, the next one, we can write that as log 1 minus log 3. So that's 0 minus 0.48. So we get 0.52. And 30 over 4, well, that's just log 3 times 10 over 4. So we get log 3 plus log 10 minus log 4. 0.48 plus 1 minus 0.60. So we should get 0.88. All right, hopefully that makes sense. If not, you know where to find me. I'll see you in class or see you on Remind. Either one.